Today is a fun day. We're going to learn about matrix inverses. So go ahead and get section 3.5 open and go ahead and get MATLAB open so you're ready to practice and take notes. So I'll assume that you've paused the video and that we're ready to go now for section 3.5 matrix inverses. Okay, so only a square matrix A can have an inverse. Why? Okay, well, what's the definition of an inverse? An inverse is a matrix B such that when I multiply A times B, it's equal to B times A, which is equal to the identity matrix. Okay, well, if you're going to be able to multiply A times B, the inner products have to match, right? The rows, excuse me, the columns of A have to be equal to the number of rows of B. Well, then when I swap, the rows of B have to equal to the number of columns of A. All right. So if the multiplications are possible, both AB and BA are possible, then we know that they have to have the same number of elements in the rows and columns of A and B have to all have the same number of elements, so it has to be a square matrix. Okay, so that's remembering what we were talking about in the earlier lesson I posted today about dot products. Now, how do we find the inverse? Well, it turns out we just take the matrix the matrix M, and we augment it with the identity matrix of the same size. In other words, M has to be square. So let's say it's n by n. If it's 4 by 4, we use the 4 by 4 identity matrix. If it's a 2 by 2, we use the 2 by 2 identity matrix, and we augment them together. And then, of course, as you're getting used to seeing, we're going to row reduce. Okay? And it turns out that something's really cool here. That when we row reduce, we row reduce all the way until the identity matrix is on the left-hand side of the augmentation bar, and the thing that's left on the right side will be the inverse matrix for M. Okay, that's cool. So the steps to find an inverse matrix is I augment. It has to be a square matrix, right? So before I'll even try to find an inverse, A has to be square, and then whatever size it is, if it's 5 by 5, I get the 5 by 5 identity matrix, which we call I sub 5. Okay, then I row reduce that augmented matrix to RREF. Now, if it's possible, right, then on the left-hand side, it row reduces to the identity matrix. But what's left on the right is the matrix inverse for A. Okay, so again, this isn't always possible. I can always start row reducing. The question is, can I get all the way to RREF and have it equal the identity matrix? Well, sometimes I can. And if I can, then that matrix has an inverse and it will be shown on the right side. So let's take a look at an example. Get rid of the ink here, jump forward. So what if we have a matrix A and we want to find its inverse matrix? What can we do? Well, let's jump over, to the MATLAB. All right. And I already have the matrix in here. Again, I got this from the online notes, okay? And so there's matrix A. But what I need to do is I need to get the 3 by 3 identity matrix, and I'm calling it I. And then little a is going to be the augmented matrix of A with the 3 by 3 identity matrix, okay? So you can see it here. And remember, the augmentation bar is between them. And why do we do that? Well, we do that when we're row reducing by hand to kind of help just see what's what. Because again, as we go through this arithmetic, numbers are going to start jumping all over the place. We'll have zeros and ones starting to appear on the left, and we'll have other numbers appearing on the right. So the augmentation bar basically helps us see where the dividing line is between the two matrices. And again, as this works, we will get the identity matrix appearing on the left and the inverse matrix of A inverse, showing up on the right. Okay, so let's try this. All right, so I have this matrix A, right? And so I can start my row reducing. And the first thing I want to do is I would like to get a positive one as my first pivot. It's just easier. You've seen me do this a lot. So I am going to take the first row of A, and I'm going to have it equal, negative the first row of A, right? Just multiply by -1. All right, so now I do have that positive 1 in the um, top left corner of my matrix A, which is going to make my second row operation pretty easy, right? So the second row of A will be equal to the second row of A minus 3 times the first row of A. Okay, now I have a 0 below the 1, so I got a positive 1 as the pivot in the first column, and then a 1 below it, and I'd like a 1 below that, and I am going to copy paste this. Why? Well, it's almost what I need, right? So for row 3 of A, I want it to equal row 3 of A minus row 1, right? Because I have a 1 in both places, so if I just subtract row 3 minus row 1, I will get a 0. Yay! Okay, so now I already have a 1 in my second column pivot position, but I'd like a 0 below it. So what's going to happen with row 3? Well, so row 3 will be equal to row 3 minus row 2. Okay, so I do use a lot of copy paste, but here it is. Row 3 of little a is going to be equal to row 3 minus row 2. And I'm doing well here, except I have a 3 in my third column pivot position. I have a 3 there. So what am I going to do? I have to take row 3 and I have to divide row 3 by 3. Right, so I'm going to divide 3 by 3 and get a 1. Now that's going to introduce some fractions. And again, this is why the augmentation bar is helpful. You can see that when things start getting a little messy and I start including some fractions, the augmentation bar, when I'm working by hand, really helps me keep things clear exactly what's what and where those things are. Okay, but what do I have to do? I only have 2 more things to worry about. I would like to get a 0 here and a 0 here. And then I'll have the identity matrix. So if this thing is possible, two more operations ought to get me where I'm going. So what do I want to do? Well, with row 2 here, remember it's a -1 above that third column pivot position. So row 2, I'm going to take row 2 and I'm just going to add it to row 3. Now I have zeros. Notice that I already had a 0 in the top row of the third column. Now I have a 0 in the second row of the third column. And now I just have this one final step to do to get a 0 above the second column pivot position. Okay, so what is row 1 going to be? Row 1 is going to be row 1 minus row 2. Right, because they both have positive 1s. So if I subtract the 2 rows, 1 minus 1 will be 0. And 1 minus 0 over here, right? So the 1 minus 0 here won't matter. The 0 minus 0 won't matter. And then just you let whatever happens over here will happen. Doesn't matter. And let me get back in here and run this. Sorry. Wow, so look at what we've got. If you go back to where the augmentation bar goes, right, I do in fact have the 3 by 3 identity matrix. So what we've done is we've row reduced A, augmented with the identity matrix, and the left-hand side is in fact the identity, and we would call this I sub 3 because it's the identity matrix for 3 by 3 matrices, square matrices, or matrices whose vectors live in R3. Okay. And then whatever is left over here, that is the matrix A inverse. Okay. So that's interesting. And I will say that, yes, are there other ways to do it? Yes. I can row reduce this augmented matrix. And remember, we defined I, capital I, up above to be the I3, EYE3. Okay. And it'll do it. And notice that we use the RATS function, the rationalize everything function, and we get some 10 thirds and 2 thirds rather than, the 3.333. And here are all of the row reduction steps that I just did, and we can do RATS A at the end. Um, and oh, okay, so A is starting here, and it just reapplied all of the same steps. That's why this is looking kind of ugly, but this is the correct row reduction steps. And what do we know from all of that? Okay, so we put the matrix A and augment it with the identity matrix of the right size. Then we row reduce to RREF. And if we get the identity matrix here, then we know that A inverse is sitting right here. And yes, the left-hand side row reduced to the identity matrix. And so then we know that A inverse is negative 3 1/3, minus 2 thirds, minus a third across the top row, 2 1/3, 2 thirds, and 1 third across the second row. And the third row is minus 2 thirds, minus a third, and a third. Okay, so that's how we find a matrix inverse. Let me just run back up to the steps, right? So you augment whatever matrix you're trying to find the inverse of with the identity matrix of the correct size. You row reduce, and if the left-hand side row reduces to the identity matrix, then the right-hand side is the matrix inverse that we were looking for. So it's just a straightforward application of row reduction. It is a little bit of extra arithmetic because instead of just adding a vector on the right-hand side of the augmentation bar, I'm adding a whole matrix. So in some ways, it's double the arithmetic. The same number of row reduction steps, but each row reduction step does require a little bit more arithmetic. So this is definitely something you should practice. It's not that hard, but it's something that's worth practice because it does require a good bit of arithmetic. So practice, 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 and good luck.